Have you ever wondered what lies beyond the familiar realm of numbers we use every day? What about the numbers that reside beyond zero, beyond the negatives, in a realm often deemed imaginary? These numbers, as perplexing as their name suggests, hold the key to unlocking some of the universe's most profound secrets. Join us on a journey into the captivating world of imaginary numbers, where we'll demystify their nature and uncover their hidden elegance. We'll delve into the heart of these enigmatic entities, exploring their historical origins, the resistance they faced, and their eventual rise to prominence in the world of mathematics and science. Get ready to discover how these seemingly unreal numbers underpin the functionality of our smartphones, illuminate the workings of the cosmos, and even help us peer inside the human body. Prepare to have your perception of numbers transformed as we journey from the concrete to the abstract, from the mundane to the extraordinary. This is not just a journey into the world of mathematics, it's an adventure into the very fabric of reality itself. So buckle up and prepare to be amazed as we unlock the mysteries of imaginary numbers together. From the moment we learn to count, we're introduced to a world governed by numbers. We use them to quantify our surroundings, measure time, and navigate the complexities of everyday life. But what happens when we venture beyond the familiar territory of whole numbers and fractions? What lies beyond the realm of the real? Imagine a world where the impossible becomes possible, where equations yield solutions that seem to defy logic. This is the realm of imaginary numbers, a dimension of mathematics that often evokes a sense of mystery and intrigue. These numbers, denoted by the symbol I, challenge our conventional understanding of mathematics and unlock a universe of possibilities. These numbers, far from being imaginary in the literal sense, play a crucial role in our understanding of the universe. They're not figments of our imagination, but rather essential tools that allow us to describe and comprehend phenomena that would otherwise remain hidden. They bridge the gap between the abstract and the concrete, enabling us to unravel the secrets of the cosmos and delve into the intricate workings of our own world. The term imaginary itself is a bit of a misnomer, a historical relic that belies the true nature of these numbers. Coined in a time when their significance wasn't fully grasped, the term has unfortunately stuck, leading to misconceptions about their relevance and practicality. But just as the word atom, meaning indivisible, initially masked the complex inner workings of these fundamental particles, so too does imaginary obscure the profound implications of these numbers. In reality, imaginary numbers are no more imaginary than any other type of number. All numbers are, in a sense, abstract concepts that we use to represent and manipulate quantities. The number 2, for instance, doesn't exist physically. It's a concept we use to represent a specific quantity. Similarly, imaginary numbers are simply a different type of number, governed by a unique set of rules that extend the boundaries of mathematical possibilities. Their elegance lies in their ability to solve problems that real numbers alone cannot. They are the missing piece of the mathematical puzzle, providing a complete and harmonious framework for understanding the universe. In the next section, we'll journey back in time to explore their fascinating origins and the initial skepticism surrounding their existence. Prepare to be surprised by the audacity of these numbers and the revolution they sparked in the world of mathematics. Our journey into the world of imaginary numbers begins not in a lofty academic hall but on the bustling streets of 16th century Italy. Amidst this vibrant backdrop, Raphael Bombelli grappled with a problem that would alter mathematical history. He sought a solution to cubic equations, expressions involving variables raised to the third power. His calculations led to the square root of negative numbers, a concept deemed absurd. But Bombelli refused to dismiss these results. Instead, he embraced the absurd, paving the way for imaginary numbers. Section 2. The Square Root of Controversy, Challenging Mathematical Orthodoxy. Bombelli's revolutionary work with the square root of negative numbers challenged the very foundations of mathematics. Rooted in Greek tradition, numbers were seen as tangible quantities, lengths, areas, volumes. Imagining the square root of a negative number was uncharted territory, defying arithmetic's familiar rules. Many dismissed Bombelli as a heretic, but he persisted, defining I as -1. This daring leap paved the way for a profound expansion of mathematics. Beyond skepticism, glimmers of acceptance. Bombelli's work on cubic equations gradually gained attention, intriguing mathematicians with his unconventional methods. His eye opened exciting new avenues, far from being a mathematical dead end. Leibniz hailed it as a wonderful flight of God's spirit, bridging being and non-being. His endorsement lent legitimacy, yet skepticism lingered. It would take another century for imaginary numbers to gain widespread acceptance and reveal their true power. Planting the seeds of a mathematical revolution. Imaginary numbers, once dismissed as curiosities, began to reveal their profound potential. Leonhard Euler recognized that combining real and imaginary numbers created complex numbers, unlocking a new mathematical system. Complex numbers, expressed as a plus bi, became essential for solving equations and advancing mathematics. Euler's insights sparked a mathematical revolution, paving the way for groundbreaking scientific and technological progress. Imagine a world where numbers are no longer confined to a single straight line, but are free to dance across a boundless plane. This is the realm of the complex plane, a two-dimensional representation of complex numbers that revolutionized our understanding of these enigmatic entities. It's a space where real numbers, those familiar friends from our everyday calculations, meet their imaginary counterparts in a harmonious blend of abstraction and elegance. Picture a horizontal line stretching infinitely in both directions. This is the real number line, home to all the numbers we know and love: whole numbers, fractions, decimals. Now imagine a vertical line intersecting the real number line at 0, extending upwards and downwards into the infinite unknown. This is the imaginary axis, the realm of I and its multiples. Every point on this plane, every coordinate in this two-dimensional space, represents a unique complex number. A complex number, as Euler elegantly revealed, is a hybrid entity, a harmonious blend of a real part and an imaginary part. It's expressed in the form a plus bi, where A marks its position along the real axis, and B denotes its location along the imaginary axis. The complex plane, far from being a mere mathematical abstraction, provides a powerful visual tool for understanding the behavior and relationships between complex numbers. It allows us to grasp their geometric properties, revealing symmetries and patterns that would be difficult, if not impossible, to discern through algebraic manipulation alone. Before the advent of the complex plane, our perception of numbers was inherently linear. We were accustomed to placing numbers along a single line, with 0 as the central anchor, positive numbers extending to the right, and negative numbers reaching out to the left. This linear model, while intuitive and useful for many purposes, ultimately limited our ability to fully grasp the richness and complexity of the mathematical universe. The complex plane shattered this linear constraint, liberating numbers from their one-dimensional prison and allowing them to inhabit a two-dimensional space. This seemingly simple shift in perspective had profound implications, opening up new avenues of mathematical exploration and deepening our understanding of even the most familiar mathematical concepts. For instance, addition and subtraction, operations we typically associate with moving left or right along the number line, take on a new meaning in the complex plane. Adding a complex number is akin to translating a point on the plane, shifting it horizontally by the real part and vertically by the imaginary part. Subtraction, similarly, becomes a matter of moving in the opposite direction. Multiplication and division, operations that often seem more abstract when confined to the number line, become intuitively clear in the context of the complex plane. They involve rotations and scaling, transforming the plane itself and revealing the geometric elegance hidden within these fundamental arithmetic operations. The true power of the complex plane, however, lies not merely in visualizing individual complex numbers, but in its ability to represent and analyze complex functions. Just as a function on the real number line maps one real number to another, a complex function takes a complex number as its input and transforms it into another complex number. Imagine a complex function as a set of instructions, a recipe that takes a point on the complex plane and moves it to a new location. This movement could involve rotations, stretches, reflections, or any combination thereof, creating intricate patterns and transformations on the plane. Studying these transformations provides deep insights into the behavior of complex functions and their applications in various fields. Consider, for example, the function f of z equals z squared, where z represents a complex number. This seemingly simple function, when visualized on the complex plane, reveals a fascinating pattern. Squaring a complex number doubles its angle from the positive real axis and squares its distance from the origin. This means that points near the origin bunch up even closer, while those farther away spread out dramatically. The complex plane allows us to visualize these transformations, revealing the inherent beauty and elegance of complex functions. Section 4. The geometry of complex numbers, unveiling hidden symmetries. Complex numbers bridge algebra and geometry, revealing a harmonious relationship. The magnitude of a complex number z represents its distance from the origin on the complex plane. Multiplying by I rotates a point 90 degrees counterclockwise, while taking the complex conjugate reflects it across the real axis. These transformations highlight the elegance and symmetry of complex numbers. Through geometry, complex numbers become more intuitive and visually striking. Section 5. From abstraction to application, building bridges to the real world. Once dismissed as abstract curiosities, complex numbers now unlock profound real-world applications. They provide the framework to describe phenomena like electricity and quantum mechanics. Complex numbers bridge mathematics and reality, solving mysteries that once baffled scientists. Next, we explore their transformative role in modern technology. Section 1. The hum of electricity, imaginary numbers. Powering the modern world. Alternating current AC electricity, the lifeblood of modern technology, relies on complex numbers. Engineers use them to represent both the magnitude and phase of oscillating currents. This dual representation revolutionized electrical engineering, enabling precise circuit design. From power grids to smartphones, complex numbers power our electrified world. Without I, the imaginary number, modern electrical systems would be far less efficient. Complex numbers simplify the intricate dance of AC electricity, making innovation possible. They are the unsung heroes of the electric revolution. Section 2. Unlocking the quantum realm, where imagination meets reality. Quantum mechanics, the science of the subatomic, relies on complex numbers. The Schrödinger equation, a cornerstone of quantum theory, is a complex valued equation. These numbers encode probabilities and energy levels essential for understanding quantum systems. Without complex numbers, the quantum world would remain an enigma. Section 3. Seeing the invisible imaginary numbers and the magic of MRI. MRI technology, a medical marvel, uses complex numbers to create detailed body scans. These numbers capture the amplitude and phase of signals emitted by water molecules. This data distinguishes tissues and identifies abnormalities with precision. Complex numbers are the hidden architects of life-saving medical imaging. They transform invisible signals into clear diagnostic images. Section 4. Beyond the horizon, complex. Numbers in weather forecasting and flight simulation. Meteorologists use complex numbers to model atmospheric variables and predict weather. Flight simulators rely on them to simulate aerodynamics and turbulence. Their ability to represent magnitude and phase makes them ideal for these applications. Complex numbers ensure accurate forecasts and safe air travel. Section 5. The music of the cosmos, complex. Numbers and the search for cosmic harmony. Gravitational waves, ripples in space-time are analyzed using complex numbers. These numbers capture the amplitude and phase of cosmic signals. They help astrophysicists decode the universe's most energetic events. Complex numbers let us listen to the music of the cosmos. Section 6. From abstraction to innovation, imaginary numbers as catalysts for progress. Imaginary numbers, once doubted, now drive innovation across disciplines. They remind us that curiosity and exploration unlock hidden truths. Imaginary numbers will continue shaping our future in profound ways. Section 1. Beyond utility, the philosophical echoes of imaginary numbers. Imaginary numbers challenge our notions of reality and mathematical truth. They exist beyond sensory perception, accessible only through mathematics. Like hidden worlds, they reveal deeper layers of reality. Imaginary numbers expand our understanding of the universe. They remind us that knowledge often lies beyond the visible. Section 2. The mind's eye. Imaginary numbers and the nature of mathematical reality. Do mathematical concepts exist independently, or are they human inventions? Imaginary numbers fuel this debate, challenging our understanding of discovery. They blur the line between mathematical realism and constructivism. Imaginary numbers reveal the complex relationship between mind and mathematics. Charting the unknown, embracing the unseen in mathematics and beyond. Imaginary numbers teach us to embrace the unknown, stepping beyond the familiar. It's in those uncertain places that groundbreaking discoveries are made. The courage to explore the unknown sparked a revolution in mathematics. That revolution transformed how we understand the universe. Science, at its heart, is about exploration and curiosity. Progress requires us to challenge assumptions and embrace new ideas. Who knows what we might discover? Section 4. The unreasonable effectiveness, imaginary numbers, and the deep structure of reality. The story of imaginary numbers isn't just about mathematical beauty. It's also this incredible testament to how deeply mathematics and the physical world are connected. Physicist Eugene Wigner once talked about the unreasonable effectiveness of mathematics in the natural sciences. He marveled at how these abstract ideas, things that on the surface seem so detached from reality, can describe and predict the physical world with such precision. And imaginary numbers? They're a perfect example of this. What started as a mathematical oddity, something that seemed to have no real-world application, turned out to be a key, like a major key, to understanding some of the universe's most guarded secrets. From electricity to quantum mechanics, imaginary numbers are the framework, the language that helps us make sense of it all. And here's the thing, their presence in physics, engineering, and beyond suggests that they're not just convenient tools. They might actually reflect something deeper, a mathematical structure that underpins the universe itself. So the story of imaginary numbers invites us to ask some big questions. Why is the universe so perfectly tuned to the language of mathematics? Is it because, as Galileo once said, mathematics is the language of the universe, or is it more about our ability as humans to find patterns and impose order on what might otherwise seem chaotic? Whatever the answer, imaginary numbers remind us of the profound, almost mysterious relationship between mathematics and reality. It's a connection that continues to inspire wonder and curiosity, even today. The story of imaginary numbers is a powerful reminder that mathematics at its heart is not merely a collection of formulas and theorems. It's a language of breathtaking beauty, elegance, and profound simplicity. It's a language that allows us to express the most complex ideas with clarity and precision, to reveal hidden patterns and connections that would otherwise remain invisible. Imaginary numbers, with their seemingly paradoxical nature and their elegant geometric interpretations, embody this poetic aspect of mathematics. They invite us to see beyond the utilitarian aspects of numbers, to appreciate their inherent beauty, and to marvel at their ability to illuminate the world around us. The complex plane, with its graceful curves and intricate patterns, is a testament to the aesthetic power of mathematics. It's a reminder that mathematical concepts can be not only useful, but also deeply moving, capable of inspiring awe and wonder in those who take the time to explore their depths. The story of imaginary numbers encourages us to approach mathematics with a sense of curiosity and playfulness, to see it not as a dry and intimidating subject but as a source of endless fascination and intellectual delight. From imaginary to indispensable, a legacy of curiosity and insight. Imaginary numbers began as a mathematical curiosity, an abstract concept with no clear connection to the physical world. Today they power our smartphones, enable medical imaging, and guide air travel, woven into the fabric of modern technology. Their journey is a tribute to mathematical exploration, shaping our world in profound ways. As technology advances, imaginary numbers will continue to unlock the mysteries of the universe. Section 1. The enduring allure of imaginary numbers. As we conclude our journey through the captivating world of imaginary numbers, we are left with, well, a sense of awe and wonder. These enigmatic entities, once shrouded in skepticism and dismissed as mere mathematical curiosities, have proven to be anything but imaginary. They have infiltrated the very fabric of our understanding of the universe, underpinning the technologies we rely on, and illuminating the hidden laws governing the cosmos. From the hum of electricity powering our homes to the intricate dance of quantum particles, imaginary numbers have woven themselves into the tapestry of reality. They have shown us that the universe often speaks to us in a language that transcends our immediate intuition, a language that requires us to expand our minds and embrace new ways of thinking. The story of imaginary numbers is a testament to the power of human curiosity, our relentless drive to explore the unknown and to seek out the hidden connections that bind the universe together. It is a story that reminds us that the most profound discoveries often lie hidden in plain sight, waiting for a curious mind to recognize their significance and unlock their potential. Section 2. Embracing the universe of numbers. The journey into the world of imaginary numbers is truly an invitation to expand our understanding of what numbers are and what they can represent. It challenges us to see beyond the limitations of our everyday experience and to embrace the abstract beauty and elegance of mathematical concepts. For in the realm of mathematics, the impossible often becomes possible, and the seemingly unreal can reveal profound truths about the nature of reality itself. As we have seen, imaginary numbers are not merely tools for solving equations. They are keys that unlock hidden doors in our understanding of the universe. They allow us to describe and manipulate phenomena that would otherwise remain beyond our grasp, revealing the intricate dance of energy, matter, and information that underpins the cosmos. The universe of numbers, far from being a dry and abstract realm, is a vibrant and dynamic landscape, full of surprises and hidden connections. It is a landscape that invites exploration, a playground for the curious mind to wander and marvel at the intricate beauty of mathematical structures. Section 3. An invitation to explore. As we bid farewell to the fascinating world of imaginary numbers, let us carry with us the spirit of curiosity and wonder that fueled our journey. Let us remember that the pursuit of knowledge is an ongoing adventure, a journey without a final destination. The universe is full of mysteries, and mathematics provides us with a powerful language to explore its hidden depths. Whether we are gazing at the stars, marveling at the complexity of the human brain, or simply pondering the elegance of a mathematical equation, let us approach the world with a sense of awe and a thirst for understanding. The world of imaginary numbers has shown us that the most profound discoveries often lie hidden in plain sight, waiting for a curious mind to unlock their secrets. So, let us embrace the unknown with open minds and a spirit of adventure, for the universe of knowledge is vast and its wonders are endless.